Yeah, my name's Joe. I'm a software engineer at Google working on Bazel. And before we start, I'd like to thank Benjamin for your mention yesterday. And I didn't expect that. Right, and he's right. There's no one weird trick to this project, Project Skymeld. And yeah, sorry for the clickbait title. I'll make up for that by skipping right to the good stuff, right? We did some stuff, and we walked away with 26% less in wartime. But oh no, what's that? Yeah, I guess you have to stick around to find out. Yeah, if you do decide to stick around, here's how the story goes. Background idea, proof of concept, implementation, performance, and finally the next steps. Right, and yeah, so first let's go all the way to the beginning and talk about the background and idea of this project. In one sentence, it is about making Bazel faster by merging the analysis and execution phases. How do we do that? How come by merging the phases we make Bazel faster? To answer that, let's look at a typical Bazel build. So at the top corner here, you can see like a fictional target, full A, and we are just building that with Bazel. So what actually happens behind the scene? First of all, we target pattern parsing. So this is where Bazel tries to make sense of your target pattern. For example, you specify ... Bazel will figure that out. What do you mean? And yeah, just a small, by the way, this is just here for completeness. This phase is not really relevant for the rest of the talk, so you can just ignore that moving forward. The second phase is the loading/analysis phase. Now, we got the target pattern, and this is where we load the packages, apply the configuration to the targets, and prepare the actions, basically come up with a game plan for what we're going to do during execution. And yeah, as we have the analysis result for that. And finally is the execution phase, where we actually, execute the actions and get the output that we want. Right, so what about multi-target builds? It's not that much different, actually. It's just more of the same thing. During loading and analysis, instead of analyzing one target, we analyze three, let's say in this case, because the package full has three targets, A, B, and C. And same for execution. We just execute more action. Right, but what if, let's say, target A takes a lot longer than B and C to be analyzed? What do we do with the knowledge of B and C that's already available here? Yep, nothing. We just wait, and it's actually observable in one of the JSON profiles that we have here. At the top left corner, you have the CPU counter, which tells you the CPU utilization throughout the build. Right here, you have the analysis phase. And if you look closely, towards the end of analysis, we basically have a lot of idle CPU resources. We just are doing nothing with it. And this is exactly how we can make Bazel faster by merging the analysis and execution phase. Or in other words, using this CPU resource to start execution early. Right, so that was the idea. That makes sense. But this is an expensive investment, like in terms of time. So we decided to first make a proof of concept to see if it's worth it. Right, so the goal of this is to simply verify that in the best case scenario, Bazel with merge analysis and execution phases would outperform regular Bazel in terms of wartime. And yeah, I cannot stress enough that this is the best case scenario. So we don't have all the good stuff like error handling or action conflict checking, none of that. And why do we wait in the first place? By the way, this diagram of the phases of Bazel will come up again and again during this talk. So this is how Bazel do it with all the phases. Why do we wait here? The answer to that is we need the analysis results because execution doesn't come for free. You have to do a bunch of setups for that. and that requires the full analysis result. Yeah, so what do we need to do? We need to, well, for this proof of concept, get rid of those steps or move them somewhere else, just like don't care about them. And then we can go ahead and merge the phases. Yeah, I'm not going to go into details here, but yeah, that's basically what happened for a proof of concept. Right. So in the end, we have a prototype with a single phase loading, analysis, and execution. Yeah, and the targets A, B, and C basically move independent of each other, which is what we want. And then what we did was forgot about this. So if C happens to have like a really short analysis but a really long execution, it's good that we start early because we can save some time there. Right, so we did some measurements, and the result is 40% of world time saved. Yeah, and this is, just to clarify, with async execution, which is another experimental feature that I'm not going to talk about today. And this is with remote execution and remote caching. And at this point, we are like 40%, just like, shut up, we'll do it. And yeah, that takes us to the next part, which is implementation. Now, for this part, we are gonna go deep into the technical side of Bazel. And yeah, this is the familiar diagram that we saw just now, all the phases of Bazel. And to merge the analysis and execution phases, we need to solve two main problems here. One is to continue with execution after having analyzed a top-level target without waiting for the other. And basically, we need to find the duct tape here. And secondly, if you recall, the problem here is we have the setup steps before execution. And the second problem is we need to either like get rid of that or find a new home for them because we no longer have a clear boundary. Right, so the first problem. Again, this diagram with the three phases. This is regular Bazel, and this is where we start. This is where we want to end with a single loading, analysis, execution phase. And to do that, the solution was to do it all within Skyframe. And like, okay, what is Skyframe? I got you. This is a quick note on what is Skyframe. And basically, it is, I would say, it's the core of Bazel. It is Bazel's functional evaluation system. And if you imagine Bazel is a car, then Skyframe is the engine. It's the thing that drives Bazel forward. And it consists of three components. The first one is a sky key, which is lightweight, and it is basically the key to your node in the evaluation graph. Sky function is where the bulk of the logic resides, right? So the task is like, given the sky key, you use the sky function to compute a sky value. And the sky value is basically the result that you want to take away from Skyframe. And it is cached in the Skyframe graph by default so that you can have all the nice incrementality and so on. Right, and if I were to overly simplify things, I would say Bazel is nothing but a bunch of Skyframe evaluations plus extras. Yeah, and it is actually not that far from reality. Like this is, again, the same diagram of three phases. The analysis phase is basically you give Skyframe a bunch of action lookup keys, and you expect action lookup values from it. And the execution phase is where you have a bunch of completion keys, and you expect to have completion values from the other end, right? So in order to merge analysis and execution, you would want something like this. You would want to give action lookup keys to Skyframe and get completion values from the other end, right? And how do we do that? With this new concept called build driver key, right? And what is build driver key? Is basically another sky key that wraps around the action lookup key, which is the input of the analysis phase. And just think of it as a wrapper. It will be evaluated with the build driver function, which is, I'll say, the heart of Skymeld. And it does two things here. First, it extracts the action lookup key and perform analysis on that. And then it takes the result of the analysis and immediately launch execution for that top-level target, all within this Sky function. So you have a nice continuation without having to wait for the other targets. And finally, you have a build driver value, which is, again, another wrapper around completion value. And yeah, this is where you can extract the result of your build. Yeah, so this was relatively simple, just a bunch of wrapper and then we're done. The second problem is a little harder because, well, Blaze was built a long time ago and it has a lot of assumptions around the boundaries between places. And first we look at, okay, what exactly are we dealing with here? And luckily we were able to categorize them into two categories. The first one is really easy. These setup steps basically do not need any result for analysis. They're just there because you want to do it right before execution. So that's easy. We just move them somewhere else and don't care about them. The other group is a bit more complicated, right? Because they actually have to make use of the analysis result. And how we do this is we supply the info to these setup steps incrementally. And to demonstrate that, I will go into one specific example of action conflict checking. And yeah, this is a case study. How do we do action conflict checking within Bazel right now? So the way it works is from the analysis results, you extract the whole action graph, and this gives you all the outputs within the build that you would expect. And then you check if there's a conflict among them. So yeah, once again, two actions will conflict with each other if their outputs either have the same path or one path is a prefix of the other. Yeah, so that's a conflict. Right, with Skymeld, there's no analysis result. How do we get this collection of actions? We need to collect the actions and check for conflicts incrementally. And yep, so let's say in this particular example, you have target A and C. The moment C is done with analysis, we send the actions of C to this incremental artifact conflict checker, which is a mouthful, but yeah, it's basically a central repository that for all the actions that has the global view. And yeah, once C is done with analysis, we send all the actions of C there. Same for A, and yeah, then this centralized repository will have the whole picture and will be able to detect if there's a conflict. Right, and yeah, turns out this high-level idea is applicable to many of the similar problems. So things like after analysis callback and so on, we can just incrementally provide the analysis info per top-level target as soon as they're available. Yeah, so that's just a crash course. If you are interested in more information, these two files are helpful, and you can find them in the Bazel codebase. Right, so yeah, with that, we slowly adapted all the setup steps to Skymeld. And that's when we were able to solve the second problem as well. And yeah, and then we have this desired end state of one single block of loading, analysis, and execution. And that's when we declared, good enough, it works, and moved on to the good part, which is measuring the performance. Right, and before I talk about that, I would like to talk a bit about which builds do we expect to benefit the most here, like the target audience. And of course, the must-have is you must have a multi-target build, because if it's a single target build, there's no waiting, right? And second of all, if your build happen to have a long-tailed analysis, that means like a very long analysis operation that is forcing everyone else to wait before they can execute, yeah, this would help. And yeah, we did an internal benchmark. This particular target was like an IDE target with like more than, an IDE built with like more than 1,000 targets. And of course, this was done with remote execution and caching. And we saw a 9% improvement in wall time. And then we tried with the same benchmark, the same setup with just a beefier machine, 72 core. And the result was 26%. It's like, okay, what's going on? Then we looked at the profile, and turns out there's a long tail analysis operation that took 33 seconds that's holding everyone back. And yeah, Skymeld really helped us here, 26%. And since we're at BazelCon, I think it's like sort of uncool if I just show the results of internal benchmarks. So I did a benchmark with the Bazel code base itself. How about Bazel build ... And we saw a 9.7% improvement. Again, with full remote cache. Yeah, it was saving around 10 seconds. And like, okay, 10 seconds, what's the big deal? 9.7%, yeah, that's a bit better. Yeah, but you know, the layoffs are happening a lot nowadays, so I need to find a better way to verify my impact. So I looked deeper, right? So we are not expecting to save any execution time here. Like, it's all coming from analysis. And we spent about 59 seconds on the analysis phase. And that's like, wow, 17% of the analysis phase. And if my manager is listening, it's 17%. Yeah. Anyway. Right. So that was it. Next steps. There is a risk with this project, though, because all the incremental stuff doesn't come for free. You have to pay the extra heap cost to maintain all the states, at least during the builds. So there's a risk there. And we still need a lot of polishing to do. I mean, there's like $50, if I remember correctly. Yeah, but we're actively working on it. And the rule of 3 means that I have to come up with the third item, which is, yeah, please consider Skymeld. If your builds actually fit the profile, you can give it a try. And it's really simple. You just flip a flag and that's it. And I'll send out more information when it's ready. I totally forgot to put the flag name there. Yeah, and by the way, this is a live view of, well, not live, a screen recording of Bazel doing analysis and execution at the same time. And with that, I thank you.